Wasacom, learning without boundaries.
Welcome to our video today. Today we shall be introducing the topic of the mole. And what is the mole? Most students find the mole to be a difficult concept, mostly because from the word go, they don't understand what it is. Well, the mole, as I can define, is simply a name given to a specific number of items. Well, just like a dozen. If you say you have a dozen of anything, what you mean is that you have 12 items of that particular thing. For example, if I say I have a dozen of avocados, a dozen of the sweet avocados, what I mean is that I have 12 avocados. Well, just like a dozen, a mole of anything is also a name given to a specific number of items. And which is that number? Well, let me warn you, it is quite a big number. The number is what? That is a huge number to do calculations with. Imagine putting all these zeros in a calculator. You are likely to forget some. Well, don't worry. There is a way we can make this number simpler by giving it a scientific notation. And how do we do that? This is a very huge number to do calculations. So how do we make it easier for us to do calculations? Well, if we put our decimal place here, we just need to move it across up to when we'll have only one number on my left side. And then we have to count the number of times we have moved the decimals. So let us start together. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I have moved my decimal to the left 23 times. So how then do I write that number? I simply write it as 6 point, because I've moved the decimal point 23 times, 0, 2, 3, I can reach up to there, times 10 to the power of 23. So a mole of anything therefore, we can say it has 6.023 times 10 to the power of 23. Now that number is given a name, and we call this number 6.023 times 10 to the power 23. We call it the Avogadro's number. It is named after the scientist who discovered the number of particles, the number of items, the number of atoms, or the number of particles that could be in a mole of anything. So to recap that very fast, we have said that a mole is a name given to a number of things. Just like we said, a dozen has 12 things. A mole has this huge number of things, 6.023 times 10 to the power 23, and that number is what we refer to as Avogadro's number. It is given a notation L. So you would imagine that having such a big number, 6.023 times 10 to the power 23, the atoms, or rather the items, would occupy a very big space. However, in science, we deal with very small particles. we deal with very small particles. 6.023 to the 10 times 10 to the power 23 of particles occupy a very small space, and I will illustrate that using sulfur. If you take sulfur for example, and I weigh 32 grams of sulfur. If I weigh 32 grams of sulfur, so what I have here is 32 grams of sulfur. I hope you can see 32 grams of sulfur. So as I'm saying that in science we deal with very small particles. We call them atoms or molecules or ions. Therefore 6.10 to the power 20, 6.023 times 10 to the power 23 number of particles occupy a very small space. For example, what I have here is sulfur, 32 grams of sulfur. In these 32 grams of sulfur, what is contained is 6.023 times 10 to the power 23 particles. Why? Because sulfur has an RAM of 32. 1 mole of sulfur, therefore, has a mass of 32 grams. The RAM of sulfur gives you the mass of 1 mole of sulfur. Thus, 6.023 times 10 to the power 23 atoms of sulfur has a mass of 32 grams. So what I have here, the 32 grams of sulfur I have here, if I was to count the atoms of sulfur one by one, I would have a total of 6.023 times 10 to the power 23. Now next, I'll show you how to determine the number of particles in any given mass. However, it is good first of all to understand that the RAM of any element gives you the mass of 1 mole of that element. The RAM of any element gives you the mass of 1 mole of the atoms of that element. For example, here I have hydrogen. The RAM of hydrogen is 1. The relative atomic mass of hydrogen is 1. The molar mass, therefore, or the mass of 1 mole of hydrogen atoms, therefore, is 1 grams. And that is why the units for molar mass is grams per mole, because molar mass is the mass of 1 mole. How many particles, therefore, will be in 1 mole of hydrogen? 6.023 times 10 to the power 23, as we have said. Let me give you another example. We have carbon. The RAM of carbon is 12. What is the mass of 1 mole of carbon atoms? As your guess, 12 grams. Why? The RAM gives you the molar mass, or the mass of 1 mole. How many particles will be there? It is our big number, 6.023 times 10 to the power 23. Good. Let us go to sulfur. We have just said that the RAM of sulfur is 32. What is the molar mass? Let me give you a second to think about it. Exactly, you're correct. The molar mass is 32 grams per mole. The mass of 1 mole of sulfur is 32 grams. How many particles are there? I give you 1 second. Good. 6.023 times 10 to the power 23. Let us go to iron. The RAM of iron is 56. What is the molar mass of iron? I know that by now you know it is 56. The RAM gives you the mass of 1 mole. And what is the number of particles in 1 mole? 6.023 times 10 to the power 23. So what can we conclude therefore? 1. The RAM gives you the molar mass, or the mass of 1 mole. The number of particles in 1 mole of anything will always be 6.023 times 10 to the power 23. And this is what makes it even easier. You'll always be given the RAM. In any question, you'll always be given the RAM. Student, when you're given the RAM, remember, you've been given the mass of 1 mole of the atoms of that particular element. So, now come with me and see how then we can calculate the number of particles in any mass of a given element or substance. So what I have here is 2 grams of iron filings. We want to see how many atoms of iron filings do I have. I have 2 grams of iron filings. How many atoms of iron filings do I have? Let me see. We start by determining the RAM of iron filings. And I told you you'll always, of iron, I told you you'll always be given. The RAM of iron is 56, right? Therefore, the 1 mole of iron has how many grams? 56 grams. How many particles are contained in 1 mole of iron? We said 6.023 times 10 to the power 23 atoms. So 1 mole weighs 56 grams. Why? Because the RAM is 56. Number of particles is 6.023 times 10 to the power 23. Why? Because the number of particles that are found in 1 mole of any substance is 6.023 times 10 to the power 23. Therefore, how do we determine now the number of particles in our 2 grams? We simply say 56 grams has this number of particles, 6.023 times 10 to the power 23 atoms. You simply ask yourself, what about our 2 grams? And it is very easy. I always say cross multiply. 2 times 6.023 times 10 to the power 23, divide that by 56. Multiply this by this, divide by this. So divide by 56. So you put our values, or you put the values directly into your calculator and you do your calculations. 2 times 6.023 times 10 to the power of 23, that one you divide by 56. What you get is 2.151, can add 1 times 10 to the power of 22. Always look at your calculator. Most students will always rush to 23, but always look at your calculator correctly to transfer the correct answer. So 2.1511 times 10 to the power of 22. So our 2 grams of ions has this number of particles. So let us try another question here. You're asked, how many atoms are there in 20 grams of calcium? How many atoms of calcium are there in 20 grams of calcium? Again, it is very easy. How do you do that? You simply take 40 grams. Remember we said that this is RAM. It gives you the mass of 1 mole. And in 1 mole, the particles or the atoms that are there is 6.023 times 10 to the power of 23. Then you're being asked how many atoms are there in 20 grams. So you simply ask yourself, what about 20 grams? So you simply cross multiply. So you say 20 times 6.023 times 10 to the power of 23, you divide that by 40. Again, I said you put the values in your calculator. 20 times 6.023 to the power times 10 to the power of 23, divide that by 40, you will get 3.0115 times 10 to the power of 23 atoms. And you can see that if 1 mole of calcium has 40 grams, 20 grams is half the mass. Therefore, the number of particles will also be half the number of particles in 1 mole. So half 6.023, you'll get it is exactly this. We have another question here. Calculate the mass in, now this time we want to determine the mass in 3.0115 times 10 to the power of 23 atoms of aluminium. You're told the RAM of aluminium is 27. Again, you start by saying that 27 grams of aluminium will have how many number of particles? If this is the RAM, this is the molar mass. The number of particles in 1 mole is 6.023 times 10 to the power of 23. And you'll always be given this. You'll always be given the Avogadro's constant to use. So I'm using this one because it is the one that I've introduced with. So we want now to know the number of particles, the mass in this number of particles. So we are saying 27 grams, that is the molar mass, has this number of particles. So you ask yourself, what about 3.0115 times 10 to the power of 23? Again, you simply cross multiply. 27 times 3.0115 times 10 to the power of 23, you divide that by 6.023 times 10 to the power of 23. You put it in your calculator. So you come and say 27 times 3.0115 times 10 to the power of 23 divided by 6.023 times 10 to the power of 23, and you will get 13 is equals to 13.5 grams. So the mass in this number of particles or atoms is 13.5 grams. And again, you can see this is half the number of particles in 1 mole, and 1 mole is 27 grams. So the mass that you get here is 13.5 grams. But even if you're given these in the exam, make sure you do the calculation, because the marking point is in your calculation. So don't simply say it is a half and write 13.5. Make sure that you show this working, because that is where the marking point is. Now, this is a question I want you to try and write the answer in the comment section. When you watch the video, in the comment section, try and write the answer. If 54 grams of aluminium were obtained from aluminium ore, how many atoms were obtained? So if 54 grams were obtained from aluminium ore, of aluminium obtained from aluminium ore, how many atoms were obtained? The RAM of aluminium is 27. The Avogadro's constant I want you to use is 6.023 times 10 to the power of 23. Do your calculation and then you write the answer in the comment section. Just to summarize that, what is a mole? We have said that a mole is a name given to a specific number of things, and we've said that the number of things is 6.023 times 10 to the power of 23. And we've said that in any calculation you'll always be given this number, so not to worry. 6.023 times 10 to the power of 23. What else have we seen? We have seen that the RAM of any element gives you the molar mass of that particular element. What you're saying is that the RAM gives you the mass of 1 mole of atoms of that element. The number of particles in 1 mole, we have said, is the same. The mass would be different, but the number of particles will be the same. With this information, you can easily calculate the number of particles in any other given mass, or the mass in any other given number of particles. In the exam, you'll always be given the RAM and you'll always be given the Avogadro's constant. So up to that point, it is as easy as you have seen. Thank you, and remember to subscribe.